All right, good morning, guys. Hopefully you can hear me. Let me just quickly go through the stuff that you had gone through. So where was I? SEP. Blah, 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 blah. Just give me a minute. I need to find that particular paper. I'll forget about it. All right. You have the question paper, yeah? So have a look at the question paper. I'm just about to start in a little bit. I don't know why that is not working now. Just give me a minute. Huh? Okay, should be all right now. Okay, I found the paper. Okay, all of you can hear me, hopefully all right. So I'm just gonna show you how to get to the answer essentially. So, I mean, a lot of people already mess up the multiple choice questions, yeah? This paper is marked out of 42 and then it's converted to percentage. So, I mean, credits would be 60% and above. Anything below 60% is not an all-level credit, just so you know. Now, in this first question, you have physical changes. So physical changes mean not chemical change. So usually when we look at physical change, we just look at change of state such as melting or boiling, that is physical changes. Other physical changes include solid going to liquid is melting, and then liquid going to solid is boiling, and then, liquid going to gas is boiling, gas going to liquid is condensation, and then liquid going to solid is freezing. These are all lower secondary science. These are all primary school science, and you have just learned in the context of physical changes in year 10. So the answer must be B there. Now, question number 2, this is about formula. Aluminium sulfate, according to the question there, and according to the information given here, you have 3 and 2. You will label valency based on the charges, and then how many of the ions have to combine together. That is you doing the cross multiply, the crisscross. So 2 there means 2 of that Al3 plus, and 3 there means 3 of that sulfate. So you know the formula has to be 2 of that aluminium and 3 of that sulfate there. As for the other one, sodium phosphate, according to the formula given in the question, sodium phosphate. So there's 1 and 3. Again, you exchange the valency to give you how many. This is your primary school lowest common multiple, LCM. So you need 3 of the Na plus and 1 of that PO4. There can only be one answer there, which is option A there, year 9 chemistry. Now the next one, a few things to underline and circle. You will see that the reaction is repeated. You do it again at a different temperature, but this different temperature, rate of reaction increases. If you look in your syllabus, I keep on mentioning this syllabus. In case you don't know what is happening, I'm just going to show you what is happening. Under your combined science curriculum, in the notes, give me a minute. In the notes, that's wrong. Where am I? Rate of reaction topic, right? Rate of reaction topic. So you will see that at the beginning of the topic, you would have the learning objective, sort of like this. So candidates should be able to, these are straight from Cambridge syllabus. They expect, they want the students to be able to describe the effect on the rate. As you increase concentrations, there are more particles per unit volume, so rate will increase. When you add water to solutions, you make it more dilute, you make it less concentrated, and therefore rate will decrease. Surface area increases, rate will increase. Temperature increases, rate would get higher. It will be faster reaction as well. Using catalyst would increase the rate of reactions. Not using catalyst would be slower reaction. Explain that catalyst is unchanged because catalyst is not used up at the end of reaction. These are all from the Cambridge syllabus. It's not a lie. They basically tell you 3 years in advance. So you need to know that next year you have been warned, you have been told what will come out. It's just that you did not go through each and every one of them. So when the rate increases, you must be higher temperature, lower temperature must be wrong. And then that is a result of you are meeting each other more often. You say collide more frequently. More frequently is also known as more often. It's just playing around with the English word there. Question number 4 is straight from the year 10 redox topic. In the redox topic, this is quite the same exact question from your work, which we did corrections, which we explained everything from the very beginning. Now we know reducing agent, what does it do? It reduces the other substance. It causes the other substance to be reduced. But because the other substance is being reduced, what happened to itself? Itself will get oxidized. Itself get oxidized. This is the definition of reducing agent. So you look for something that gets itself oxidized. This is gaining oxygen. CO has become CO2. It gains oxygen. So this has been oxidized. Itself get oxidized because it causes this thing to lose oxygen. It causes this thing to be reduced. This is a reducing agent. If I'm a killer, I kill someone. If I'm a reducing agent, I reduce the other substance. Okay, so it's got nothing to do with the gaining and losing of mass because it's down to the definition of oxidation and reduction as stated in the syllabus, which I won't show you again. You go back to your notes and you look it up for yourself. Question number 5, you add some water. If you have some syrup solution, you add water, the syrup solution becomes less sweet. That's because it becomes less concentrated. Now, when you add water to the mixture, concentration will decrease. And when concentration decreases, rate will decrease. So what happened to the rate? The rate decreases, as simple as that. Question number 6, a lot of people choose this option number A, and that is very, very worrying because you know that the A contains not 78% of oxygen, but 78% of nitrogen, 21% oxygen, 1% other gases. This is all from primary school science. This is all from lower secondary science, and now you're in year 10, and some people still cannot get that. Incomplete combustion of fossil fuels, that will give you carbon monoxide. So carbon monoxide is toxic, it's poisonous to us. So, you know, people have written quite some long stuff in their work, environmental chemistry work too. But then it just comes down to the syllabus where they say carbon monoxide is toxic. Let me just show you where it is because people do not believe me when I told them that it is in the syllabus. And then people never really gone through the syllabus one by one. So this is under environmental chemistry. Where does carbon monoxide and carbon dioxide come from? You need to mention the carbon containing fuel. Complete combustion gives you carbon dioxide. Incomplete combustion, carbon monoxide. Now decomposition of vegetation gives you methane. Burning plastic can give you harmful and toxic gases from burning of plastics. Those are toxic, just like carbon monoxide is toxic gas. State the effect. Carbon monoxide is toxic. That's it. Okay. Now going back to the test itself. So I want to cover everything. So let's move on. Contributing the most to global warming. So if you go back to the notes on environmental chemistry, methane that comes from vegetation and livestock animals, carbon dioxide from burning down forests, from burning down complete combustion of carbon containing fuel. Those two will give you global warming there. That's it really on the multiple choice questions. So onto this one, a lot of people, they just leave the diagram as like that. That is wrong. So what I've written down here is not really the answer on its own. So you should really read the question. There are two different answers. Okay, both of them are accepted. You're supposed to show label, apparatus, complete the diagram. If you don't complete the diagram, you don't get any 2 marks. If you don't label the apparatus, you don't get the 2 marks completely. The best apparatus to use is something called gas syringe because we are measuring, we are collecting the volume of gas produced. Make sure you show some lines because that's what gas syringe is for. And make sure you label the apparatus and make sure you have it sealed there. This is the piston that can be pushed up and down. This is the gas being produced and they are sealed here. So the gas will get collected inside here. The other alternative is to collect over water. So you will have measuring cylinder. So this is another alternative. This is using measuring cylinder. They have lines like that. And of course, you collect this over water. And these are all from the rate of reaction topic. I can show you where it is, but you know better where your stuff is and whether you actually done the lesson and revised the stuff or not. Now, this is between calcium carbonate and acid. They will give you calcium chloride, which is your salt. They will give you carbon dioxide gas, and they will give you water as well. These are year 9 general equations. So the test for carbon dioxide, do not mention test for carbon dioxide here, okay? You got to state. There were 3 tests for gases. I think I remember. If I remember correctly, I forgot where I put it already. Never mind. I'll send it to the group chat again later on. But I've already stated the 3 gases that you need to test for. These are from the rate topic. The test for gases. You have oxygen, you have hydrogen, you have CO2. Bubble the gas through lime water. We use this term called lime water. It's actually calcium hydroxide, lime water. And the lime water will turn milky and cloudy as you bubble the CO2 gas into the lime water. It turns milky, M-I-L-K-Y, or it turns cloudy. Basically, it's a white solid then. Okay, hopefully you have copied this down because you're expected to complete your corrections and find out what went wrong, because otherwise you're treating just every single test as whatever it is you treat it as. This is the exact same question, but you're not collecting the gas. You're allowing the gas to escape. Here, you're using a thermometer to measure temperature. This is a metal carbonate plus acid. So hopefully, you know, metal carbonate plus acid will give you metal salt all the way in year 9. So hydrochloric acid give you a chloride salt. You get a carbon dioxide gas and you get water. Name the gas. So formula will not be credited at all because name the gas, carbon dioxide, 2 oxygens, 1 carbon. State the type of reaction, temperature increases. Some of you couldn't get this word exothermic because I don't know. I mean, we have only done this topic not long ago. This is under chemical energetics. This is topic 16, exothermic and endothermic, 2 words in this topic. State exothermic reaction, release heat energy to the surrounding. You get an increase in the temperature of the surrounding. Why does the solution get hotter? What is the type of reaction? Exothermic reaction, because the solutions get hotter. There are some other stuff in here. These are all what candidates should be able to do. And if candidates are not able to do, you can't blame Cambridge and you can't blame other people but yourself for not preparing. How does the student know the reaction has stopped? This reaction produces gases. Very easy. When there is no more gas, you don't see any more bubbles. I have spelled that incorrectly. A bubble should be B-U-B-B-L-E-S. You saw bubbles because they were gases. Now you don't see any more bubbles because no more gas is being produced. What is the method used to separate unreacted solid? You have solid and you have the mixture, which is solution. How do you separate solid from solution? You filter. The Malay word is called tapis, and the English word, which is the only word accepted by Cambridge, is called filtration. The next thing, lower concentration, is the exact same question from multiple choice. When you add water, lower concentration, rate decreases. What is the effect on the rate? Read the question on the rate. As concentration decreases, rate decreases. Okay, lower means decreases. What are the other factors that affect the rate? They want other, so you cannot use concentration again. You can say temperature. You can say surface area of the carbonate. Because the carbonate is a solid, you cannot say pressure of the gas because you are not reacting gases together. You're reacting a solid and a solution. Dilute hydrochloric acid means aqueous. Aqueous means dissolve in water. Dissolve in water means you have a solution. You have a mixture, element component mixture. Lower secondary science as well as year 9 chemistry. Okay. The next bit, this question, the equation is given here. You already seen this reaction quite a lot of time. I took a hydrogen peroxide, colorless liquid. I put in some black color solid, manganese 4 oxide, which was this thing, manganese 4 oxide or manganese dioxide. So it's MnO2. This is a black color solid. It is a catalyst. So what does the catalyst do? It increases the rate of decomposition of this hydrogen peroxide. You are allowing the gas to escape. So oxygen is a gas. The gas escapes. When the gas escapes, you will have a loss in mass. You will have a decrease in mass. That is why the mass of flask and contents decrease in the trial 2 to 4, because you added in some catalyst. So this is the catalyst. And then when you use a little bit of catalyst, so catalyst is not used up. According to the syllabus just now, Cambridge says candidates should be able to understand that catalyst is not used up. What you put in is what you get out at the end of reaction, because it is a catalyst, not a reactant. It does not react, not a reactant. It is not used up. Go back to the rate of reaction topic, because people do not believe me. I just need to go through the rate topic. This is from chemical reaction, rate of reaction. Candidates should be able to explain that a catalyst is unchanged. Catalyst is not used up at all. It simply increases the rate of reaction. It simply increases the rate of reaction, make it faster. Why does the mass decrease? Because there is a loss in gas. The reaction produces oxygen gas. This is not carbon dioxide. Some people, even in year 10, some people still cannot read at all, which is very worrying. Year 10 cannot read anything at all. Cannot read in year 10. Okay. Now, what effect does the mass? Again, reading the question. Yes, using catalyst will increase the rate. But what effect does the mass? You got to read the question, the mass. So by changing the mass of manganese dioxide, go back to the table. As the mass of manganese dioxide changes, does the decrease in mass changes at all? So the time taken for the reaction to finish, as I use more and more manganese dioxide, the time for reaction to finish actually decreases. Oh, okay. I think I must have marked your question paper incorrectly. So please do give yourself some marks. I'll check back your paper later on. So this one I said no effect, which is actually wrong. This is actually wrong, because you can see as the mass of manganese dioxide increases, the time taken for the reaction to finish decreases. So the rate is getting faster. So I should say, as the mass of the manganese dioxide increases, so I'm going straight back to the table. My answer is wrong. You might need to give yourself some free marks. Yeah. As the mass of manganese dioxide increases, the time taken decreases, but they want the rate of reactions. The time taken for the reaction to finish decreases. So what happened to the rate is the rate increases. Okay. So I think I was wrong there. So give yourself 1 mark if you have gotten this correct there. I'll check back your paper later on. Now, the next thing, use the information to explain the role of manganese dioxide. So manganese dioxide is not used up. So it is not used up at all. It is acting as a catalyst. There's your second point. So the third point is it speeds up the rate of reactions. So these are all straight from the syllabus, straight from the topic content. Catalyst increases the rate of reaction. Acting as a catalyst, catalyst is not used up at all. These 3 points give you 3 marks as stated in the syllabus under the learning objective. Cambridge never lie. It's just that students do not believe Cambridge, and therefore they do not know how to prepare very well for Cambridge exam. These 3 points I show you again is in your rate of reaction topic, because when you revise, you actually go through the topic content one by one, right? Catalyst increases the rate of reaction. Catalyst is unchanged at the end of reactions. The word catalyst itself increases the rate of reaction. Now going back to the question, we have a year 9, oh sorry, this is year 10 question. Identify, part 1, with reasons. What is the substance oxidized and what is the substance reduced? Which one gain oxygen? The magnesium becoming magnesium oxide. So the magnesium gains oxygen. That is oxidation. So the magnesium gets oxidized. Read the question and answer each and every bit of the question. The CO2 loses the oxygen to the magnesium, and then the CO2 loses oxygen. CO2 get reduced because it loses oxygen. Now, this thing was very badly done. Some people went all the way to cheating. I know people cheated because the value of the relative atomic mass is given here, and yet they get things which are decimal places. There's only one way they can get it, and I know. Okay, so there are a few people in the class who actually cheated their way. There are also some in 10B, 10C, and 10G who cheated for some questions. I caught this question, but I'm sure if you cheated in one question, most likely you also cheated in other question. It's just human nature, right? Now, magnesium oxide, many people make this mistake here. They saw the 2 MgO. Remember, relative molecular mass, MR, is for 1 unit. It's only for one. So when you have 2 in front, the 2 MgO, you do not look at the 2. You just look at 1 unit. And besides, 2 MgO does not mean 2 Mg. It means 2 of that thing. So you have 2 Mg and 2 oxygen, but the relative molecular mass MR is just for one thing. So 1 magnesium, 1 oxygen. Based on the information given, you don't even need a periodic table. This thing is year 9 reacting mass. I don't want to go through so much of it, but you should know how to read the question. This is 24 gram, because from the equations, it's 2 magnesium. This is MR, 24 is the MR, but I times 2 because I'm talking about reacting masses. If you know you are terrible with these kind of calculations, you need to go back to year 9 and practice those calculations. We will never go back again. Okay, because there are so many other topics and you will have so many other subjects. This is only a couple of topics combined together. So 24 times 2 for 1 magnesium. So 2 magnesium is 48 gram. This is 1 times 44 from your answer there. And this is 2 times 40, so it's 80 gram. Okay, of course, there is CO2 as well. Sorry, there's carbon as well, which is 12 gram. As you could see, 40, am I correct? And 92, am I correct? Something is wrong there. Nah, okay, never mind. I don't want to deal with that. But anyway, it doesn't matter. The ratio is definitely correct in that sense. You only want 24 grams, so you divide that by 2, and then you divide that by 2, you divide that by 2. You can do the cross multiply method. The 2 mg going to CO2. So 2 times 24 is 48 gram, giving you 44 gram. So 24 gram is X. And you know about cross multiply because that one is also your mathematics. So 48 times X equal to 24 times 44. So you just do move the 48 to the other side and you will get the exact same answer as 22 grams. And you do the same thing with magnesium oxide and you will be fine. I remember doing this for the work 1 and work 2 under redox. So it's not like you have not been shown face to face. It's not like last year you didn't learn anything, or perhaps last year you didn't learn anything at all and you never gone back to revise. It's never my problem. You need to think about, instead of blaming the rest of the world, try to reflect on what actually happened last year. Now, this also happened in physics. In terms of temperature changes, you have to consider that there is always heat loss to the surrounding. And when you want to improve the accuracy, this is called improving accuracy. Accurate, getting more to the exact value. How do you prevent heat loss? You cover this with a plastic lid and you insulate. You can insulate. This word, insulate, comes from primary school science, comes from lower secondary science, prevent heat loss. If you are in an air-conditioned room, you will wear thicker clothing, you will put blanket because you want to insulate yourself, you want to maintain the heat in the body. So you want to prevent heat loss to the surrounding. So you would use like a insulation. So you would, instead of doing it in a beaker, you do it in a plastic cup. Okay, so that will prevent heat loss. And then you cover this with a lid, and that will prevent heat loss as well. You use a plastic lid. Okay, heat loss to surrounding is the #1 factor for the inaccuracy of this kind of experiment, because this is exothermic reaction. Exothermic reaction because the temperature of solution gets hotter. You see, from 20.0 to 22.6, and then all of these started from 20.0. All of them get hotter. When the solution gets hotter, it's because the reaction gives out heat energy. The reaction gives out heat energy. That's why we see the temperature getting hotter. Some people say reaction gives out energy, but Do you see that in the table? You do not see energy in the table. What you see is you see temperature. So make sure you talk about temperature increases because the reaction is exothermic. Reading the thermometer, most people should have no problem, but I think one or two people actually make a mistake somewhere along the way, and you have lost the 2 marks just like that. People who skip these questions, well, you already throw away some easy marks, so there's nothing more I can do for you. The next bit, the gas that relights a glowing splint. A glowing splint is without the flame, it's just the flicker, and oxygen is the one that relights glowing splint. Hydrogen is the one that you use a lighted or a burning splint, the one that still has the fire, and then it will burn with a pop sound. Carbon dioxide will turn lime water milky. Now, in terms of maintaining the amount of heat supplied, if I'm not mistaken, you have done this concept of fair test in primary school. I definitely know about lower secondary. Lower secondary, you definitely have learned this idea of fair test. You need to keep something the same. So here, the heat supply must be constant. You keep that the same so that the test is fair. But how? How do you do it? Keep the heat the same. It's very easy, keep the heat the same. You are stating back the question, you don't get any mark. How would you keep the heat the same? So you maintain the same distance. So perhaps you can clamp this on a retort stand so you don't change the position at all. You use the same Bunsen burner with the same setting. So same setting means you do not change the gas flow. You do not open or close the air hole. You do not turn it off and turn it on again. You just basically use the exact same setting. You don't turn it off. You just use it again and again. You maintain the same distance between the Bunsen burner and the test tube in every test. That's how you can keep the heat constant there. The next question was very badly done because they don't know how to read question. Again, year 10, it must involve the metal nitrate. You cannot talk about the fire. You cannot talk about the heat. You cannot talk about test tube. You cannot talk about anything except about the metal nitrate. You should use the same metal nitrate so that you have a control variable so that the test is fair. You need to keep some stuff constant so that you have a fair test, so that when you compare something, you're just determining which metal nitrate decomposes the fastest. You are changing the metal nitrate. That is what you change. You don't change the heat. You don't change the amount or the mass of the metal nitrate used. I think this is the last page. Now be careful about this. Number one, people don't know what is meant by average. Year 10, Year 10 also don't know how to do average. Now, number two, people don't know how to read bolded instruction. Do not use anomalous. Anomalous means out of ordinary. Ordinary means normal, out of normal. So if you look at the value, this is 100 and 100. This is 150. This is out of ordinary. This is 150, 300, and 320. Both of these are close to 300. This is very far away from 300. This is not ordinary, not ordinary. So ordinary means normal. So not normal, very far away. 400, 410, very close. 450 is out of ordinary. 200, 200, very close. 240 is out of ordinary. That specified do not use. If normally I would average everything, 100 plus 150 plus 100 divided by 3. Okay, normally you would do 100 plus 150 plus 100. You will use bracket because that was what I taught you when we did the work that you did, the work that you actually did, the corrections that we did, that we discussed. Averaging, primary school, lower secondary math, upper secondary math, upper secondary sciences. But then we don't divide by 3 now because we have taken out the 150 and therefore it's divided by 2 now. That is how I get the 100 and etc. etc. From this time alone, you can see that the time taken will be the shortest. Time is not fast. Rate is fast or slow. Time is short or long. This is the shortest time. So you can see lithium nitrate takes the shortest time. Shortest time for the decomposition. You want the fastest, or sometimes they will use another word, greatest rate. Greatest rate. Greatest rate means the fastest reactions. The fastest reactions will decompose very quickly, will give you the oxygen gas, and therefore the glowing splint will relight in the shortest time because the oxygen gas gets produced faster because the decomposition is the fastest here with the shortest time. So lithium nitrate is the only answer there. Okay, so apart from that one question which I had incorrectly marked, which was this bit here, the manganese dioxide, I said no effect, but it should be as the mass of manganese dioxide increases, the time taken decreases, and therefore the rate will increase there. So I think I incorrectly marked that one. So I'll have a look at your paper again and change the mark accordingly, but you would have done your own corrections on your own paper. Please mark on your own paper. I already marked it, and please give yourself the final mark and think back on what do you want from yourself in future tests and future exams when you have every single topics from the past 3 years combined together. All right, so I'm just going to stop recording, and that's it really for today. So before you leave, let me just quickly take attendance, and that is all right. Okay, cool. I've taken attendance, so thank you, everyone. I'll see you guys next time. If you got questions, just feel free to text me, and I'll be more than happy to answer your question. Thank you.
Thank you, sir.
Thank you, sir.